Phylogeny, our evolutionary history evidence. Evolutionary scientists use a classification called systematics. This is where we classify organisms determining on their evolutionary relationship. Each organism species gets their own taxonomy, which is their naming and classifying of their genus species name. It's how we name and classify organisms. Phylogenetics is the hypothesis of evolutionary history. We use phylogenetic trees to show this evolutionary history. And in order to determine this evolutionary history of relationships, scientists use evidence, which is like fossil records, DNA, protein structures, these homologous structures. We construct these phylogenetic trees. These are diagrams that represent evolutionary history of a group of organisms. These are similar to cladograms, except the trees show the amount of change over time. That is usually measured via the fossil record. Cladograms, which are a representation of lineage, each line represents a lineage, and each branching point is what we call a node. These nodes represent a common ancestor. Nodes in all the branches from it are called clades, and species in a clade have shared derived features. The root is a common ancestor of all these species, but we may not know what organism belongs at that node. All we know is that a tiger and a snow leopard share a common ancestor. When two branches they emerge from the same node, they're what we call sister taxa. A lineage that evolved from the root and remains unbranched is called a basal taxon. A synapomorphy is a derived character that was shared amongst clade members, and it derived in sync with other characteristics. These derived characteristics are similarly inherited from the most recent common ancestor in the group. Ancestral characteristics are those that arose prior to that common ancestor. Many of these cladograms and trees, they include an outgroup. This is a lineage that is least closely related to the rest of all the organisms and can oftentimes be displayed in lieu of or far from the actual cladogram, but mentioned in the diagram. A monophyletic group is one that includes the most recent common ancestor of the group and all of its descendants, which are technically the clade. A paraphyletic group includes the most common ancestor in the group, but not all of its descendants. And a polyphyletic group does not include the most recent common ancestor of all the members of the group. Parsimony. If there are conflicts among these characters, we usually refer to the principle of parsimony. This is a hypothesis that requires the fewest assumptions, means that there's been the fewest amount of DNA changes. Hands down, the easiest way to explain this vocabulary is to demonstrate it. So given the cladogram below, what is the common ancestor for butterflies, moths, and flies? Is it shown at the node A, B, or C? The answer is C. Butterflies, moths, and flies have a common ancestor at node C. What is the basal taxon? Yes, it's beetles. That's the one we hope shows up on the test, right? Now, what is an example of a sister taxa? Well, butterflies, moths, and flies are example of sister taxa. They share the common ancestor. So examine the data table below. So the positive is going to represent the presence of a trait, and the negative represents the absence of a trait. Create a cladogram that would best represent the data.